Hi boys, how are you? Welcome to today's lesson. Today we are looking at the applications of simultaneous equations. So the last two lessons we focused on the elimination and the substitution method. Today we're focusing on those problem-solving style of questions, those working mathematical questions, which notoriously are filled with words. And what we have to decipher is how do the words turn into mathematical equations that we can now go and solve. So let's look at the first question. If you want to have a crack at this, by all means, go off and do it and then come back and see if you got the correct answers. So question one, a yard is filled with cows and ducks. There are 42 heads and 96 feet. How many cows and ducks are there? So a couple of things that we need to know, of course. We know that the 42 heads, well, each cow and duck can only have one head, right? So the number of cows and number of ducks will add together to give 42. We also know with feet, cows have 4 feet, ducks have 2. So I can then use that information to work with the 96. The very first thing I want you to do each time, we need to start using some variables, and I often like you to write down what the variable is representing. If you're using X and Y, very important. Sometimes we're using things like C's and D's for cows and ducks, not so much, but I always do it anyway. So I'm going to say let the number of cows equals C. I'm going to say let the number of ducks equal D. You might use X and Y, which is fine. So now going back to that question, we said if I add C and D together, the number of cows, number of ducks, that will give me the number of heads. I know that cows have 4 feet, so 4 lots of the number of cows will give me that response, so 4C, and 2 feet for the ducks, so 2 times the number of ducks, so 2 times D, and that will give me the number of feet in total, which is 96. So now what you can see is very clearly I've created 2 simultaneous equations which can now be solved. The next step, I guess, is saying, am I going to use substitution or elimination? Well, you could use substitution if I let something like C equals 42 minus D. That's no problems at all. But you know that I kind of like to use elimination if it's set nicer like this is. I'm going to call this equation 1 and equation 2. I can identify very quickly that I can't add or subtract at the moment because I don't have the same number of cows or ducks going on here, or C's and D's. So I'm going to times the first equation by 2. Can you see why I did that? I get 2C plus 2D equals 84. I could have times it by 4, made the C's the same, but I've just chosen the ducks because it's an easy calculation. So what I'm now looking at are these are my 2 equations that I'm going to try and solve simultaneously. So I'm going to look at these, and do I add them or do I subtract them? Well, hopefully you recognize that we subtract them. So 4C take away 2C equals 2C. And I started with the top one because I want a positive number. 2D minus 2D disappears, and 96 take away 84, well, that's going to be 12, which gives me C equals 6. So very quickly, I can now say there are 6 cows. I go back to the equation. I've now got 3 options. Okay, I'm actually going to look at the first option because C plus D is really easy to use. So I'm going to say 6 plus D equals 42. Therefore, D equals 42 subtract 6. What's that going to be? 36. And I have 36 ducks. And my question is pretty much done. 2 things I'm going to do before I move on though. Okay, I'm going to finish the question off and say, therefore, there are 6 cows and 36 ducks. I'm going to go back to the question, just make sure I answered it. How many cows and ducks are there? Very clear, I've stated that. Very important, particularly if you're using things like X and Y. You need to finish the question off nicely by specifying what your answer is. The other thing I'm going to do very quickly, I'm going to just double check things. If there are 36 ducks and 6 cows, if I add them together, I get the 42 animals or 42 heads. That checks out. And then I'm going to do 6 times 4 is 24. That's for the number of feet. I'm going to do 36 times 2 is 72, which makes 96 feet. And now I can see that both of those numbers at the beginning part work out for my answer. Very quick way to quickly check out if you've made a mistake. Okay, example 2. They love questions about coins and money. John has $20 in 10-cent and 20-cent coins. There are 117 coins in total. How many of each are there? I love doing this with $1 and $2, but I've chosen to do 10 cents and 20 cents. So again, my aim is to come up with two equations that I can then go and solve, right? So first things first, I know that they've given me this number, 117 coins. So I want to start off with some variables because I know that if I have X amount of 10-cent coins and Y amount of 20-cent coins, X plus Y equals 117. But let's write that information down. Let X equal the number of 10-cent coins. Very nice and clear. I'm going to say let Y equal the number of 20-cent coins, right? Very important to write that down. The next one I'm going to say, therefore, if I add the number of 10s and the number of 20s, we have 117 coins in total. So that's the first kind of number that I've dealt with. The next bit is looking at what the value of the whole lot is. Well, I know I've got X amount of 10-cent coins. So if I times them together, I'm going to use it in dollars, so it makes it easier. 0.1x plus, if I times the number of 20-cent coins by 20 cents, so 0.2, I know when I add that together, we come up with 20. Be very careful, don't try and mix the cents and dollars, either have them both dollars or both cents and you should be okay. Now, of course, these are my two equations that I'm now going to look to solve simultaneously. Like that previous question, my issue is I don't have the same amount of X's or the same amount of Y's, so we need to modify one of them. And it's probably going to be easier to modify the bottom one. So let's call that 1 and 2. So I'm going to times it by 10, and that simply means I have X plus 2Y equals 200. You could times it by 100 if you want and make it in dollars and cents, but that's what I'm going to do. And now these two equations, 1 and 3, are the two equations that I'm going to be using. Okay, so let's come back to it. I want to solve these. Now, can I add them or subtract them? Well, again, if I add them, I'll get 2x and 3y. It doesn't work, so I'm going to minus them. But I'm going to start with the third one because I had that 2y. I want to keep it positive. So I'm going to say 3 take away 1. So x minus x is 0. 2y minus y is y. And 200 minus 117, that looks to be 83. I now know that I have 83 20-cent coins because Y equals number of 20-cent coins. Of course, if I know I've got 117, I can kind of work it out mathematically, or I can go to my equation. Number 1 looks easy. X plus 83 equals 117. I'm going to subtract 83 away from that. X equals, well, that's going to be 4, and that's going to be 3, equals 34. So let's sign it off, of course. Therefore, there are 34 10-cent coins and 83 20-cent coins. And my answer is pretty much done. Now, of course, in examination, I grab my calculator out. I'm going to double check the two questions. I'm going to double check that 83 and 34 add together to 117. I'm also going to say 34 times 10 cents plus 83 times 20 cents. Make sure that adds up to $20 as well. Gents, that is pretty much it. There's the bell as well, so that's perfect timing. Have a wonderful day. I hope this made sense, and I'll chat to you later.